Good morning, students. We have already started a chapter Physical and Chemical Changes for Chemistry subject, and this is the second video of same chapter. In previous video we have covered about element, molecules, atoms, compounds, mixtures and types of mixture, then chemical symbols. And now we will learn about next concept. So all the concept which you are going to learn in today's video, for that basic thing to know is chemical symbols and molecules. So hereafter you cannot see me on the screen, but you will see a whiteboard with some matter written on that. So you have to focus what I am speaking and at the same time what is written on the board. So today we will learn about valency, atomicity, then chemical reaction, chemical equation, and in the chemical formula section, the first thing which we are going to learn is valency. So what is valency? The valency of an element is combining capacity of the element. For this, let's discuss one example. When you come to school in van, then capacity of van is 8 students at a time. When you come to school in bus, then capacity of bus is 20 students at a time. So capacity for both this vehicle, carrying capacity for both this vehicle is different. In same manner, when two elements combine with each other, their combination capacity is different for different element, and this combination capacity is named as valency. And it is very important to know what is the valency for element, for different element. On screen you can see examples. First example is chlorine, for which we write symbol as a Cl and its valency is 1. For oxygen, capital O, its valency is 2. For hydrogen, capital H, valency is 1. For iodine, capital I, valency is 1. For helium, He, valency is 0. So this 0 is something different. Whenever any element have valency 0, then they do not combine with any other element and they can occur as a single atom. They are inert gases or stable elements. They do not react easily with other elements. More examples on this screen. Capital S for sulfur, but here you can see two numbers are written, 2 and 4. Capital C for carbon, again two numbers, 2 and 4, means some element have variable valencies like sulfur, carbon, iron means Fe, and nitrogen means N. These elements have variable valencies. It means while reacting with some element, they may use first valency, or while reacting with another element, they may use second valency. So this is valency, variable valency. Let's discuss one example. For carbon, valency is 2 and 4. So when an atom of carbon can combine with one atom of oxygen to form carbon monoxide. And when one atom of carbon react with two atoms of oxygen to form carbon dioxide. Okay, so this is because of the variable valency. Next concept is atomicity. So what is atomicity? The number of atoms in a molecule of an element is called its atomicity. Now you already know what is molecules. So from the molecules we can identify its atomicity. The chemical formula of an element is represented by the symbol of the element followed by its atomicity as a subscript. It means we have to write that number at the downside of the letter. For example, bromine. For bromine we write Br. So atom formula for bromine with its atomicity will become Br2. So 2 is atomicity for bromine. Chlorine 2. So atomicity 2. Helium 1. So for 1 we are not going to write any number. Next, hydrogen atomicity is 2. So we are writing 2 as a subscript. Then nitrogen atomicity is 2. For oxygen atomicity is again 2. For phosphorus now atomicity changed, that is 4. And for sulfur atomicity is 8. So in one molecule of oxygen there will be 2 atoms. In one molecule of phosphorus there will be 4 atoms. For sulfur 8 atoms in one molecule. For nitrogen 2 atoms in one molecule. Now I think remaining you can tell me, but I will repeat for you. For bromine there will be 2 atoms in one molecule. Same for chlorine and hydrogen, 2 atoms in one molecule. But for helium only 1 atom in one molecule. So this was for the atomicity of an element. Now we will learn about atomicity of compound. So a molecule of a compound is made up of atoms of different element in a fixed ratio that we already know, as this part was discussed in previous video. So the chemical formula of compound is represented by the symbol of its constituent element. It means when we write H2O, then the constituent elements are hydrogen and oxygen with their fixed ratio, means the number which we are writing at the subscript for the element. So now we will discuss about this example in detail. So in water, H and O are 2 elements, H and O. Now you can check in previous slide. For hydrogen, valency is 1, and for oxygen valency is 2. Hydrogen valency is 1, oxygen valency is 2. So what we have to do, we have to just cross multiply or cross this valency. So the formula will become H2O. We have to alter the valency number. The valency for the oxygen will become atomicity for hydrogen, and the valency for hydrogen will become atomicity for oxygen. One more example, NaCl. Now NaCl means sodium chloride. So sodium and chloride. So valency for sodium was 1 and valency for chlorine is also 1. So again cross linking. So Na will get 1 as a atomicity and Cl will also get 1 as a atomicity, but as you already know that we don't write 1 in a subscript, so this formula will directly change as NaCl. Okay. So there are some more groups of atoms which tend to stay together, means they have their own valencies. For example, hydroxide. For hydroxide we write OH and its valency is 1. Then carbonate, CO3, its valency is 2. Then sulfate, SO4, its valency is 2. And nitrate, NO3, valency is 1. So these are not the compounds, but these are groups which react with elements in grouped manner. They do not separate even after chemical reaction. So these groups have their own different valency. When O was a single element, its valency was 2 and hydrogen's valency was 1, but OH group, that is hydroxide group, have valency as a 1. In same manner, carbonate valency is 2, sulfate valency is 2 and nitrate valency is 1. Based on this, we will see one more example, that is sodium hydroxide. Now here in actual you can see 3 elements. Na means sodium, O means oxygen and H means hydrogen. But Na will be one element and OH will be one group. So as we discussed before, Na's valency is 1, OH valency is 1. Now just cross-link this valency. So the subscript will be Na1 and OH1. So the formula without writing number 1 in a subscript, formula is NaOH. So this was about the atomicity of the compound. From this we will learn about chemical reaction and then chemical equation. So for any element or any substance, the starting part is to know about their valency, then atomicity of element, then atomicity of compound and atomicity of some groups. Next topic is chemical reaction. Till now we have learned about atom, molecules, element, compound, mixture, but behind this is a chemistry. So chemistry consists of chemical reaction. When chemical reaction happens, then only substance change or element change to the compound. So chemical change is something irreversible, or a chemical change is a result of a chemical reaction between two or more substances. And the substances that undergoes a chemical reaction are called reactant, and the substances which are formed after chemical reaction are called product. So the left hand side is called as a reactant side and right hand side is called as product side whenever we write any chemical reaction. So for we can use another word for chemical reaction, that is word equation. So here you can see one example. Copper sulfate react with iron to form copper and iron sulfate. So reactants are copper sulfate and iron, and products are copper and iron sulfate. One more example. Here carbon and oxygen combine to form carbon monoxide. So carbon and oxygen are reactant and carbon monoxide is a product. So this thing we have written in word form. Now we will go for chemical equation. So what is chemical equation? A chemical equation is a representation of chemical reaction using chemical symbols and formulae, means all the things which we have learned till now. We have to use all that things, symbols, formulae and with the valencies, means the numbers in the subscript. So from chemical equation we can get the information of reactant which are participating in the reaction. We can get the information of product which we get after the reaction, and we can get the information of molecules of reactant and products, means both reactant and product in the reaction. So chemical equation is better than chemical reaction to gather the information about chemical change. So now we are going to discuss that how to write chemical equation. So for this we are going to take example, easiest example, that is for water. So while writing the chemical equation, first step is to write the chemical reaction in words form. So water get formed by the addition of hydrogen and oxygen. Okay, this is the step 1. Or we can write in another way, that oxygen plus hydrogen is equal to like this: oxygen plus hydrogen. Now I am having this, oxygen plus hydrogen to form water. So again the left hand side represent the reactant and the right hand side represent the product. I cannot write this in one line, but just assume that oxygen and hydrogen are in one line with water. So this was the step 1, to write chemical reaction in words. Now step 2. Write the chemical reaction using molecular formulae. So we have already discussed molecular formula for hydrogen is H2, molecular formula for oxygen is O2 and molecular formula for water is H2O. Now you have to observe this reaction. We have to balance this reaction on both the side, reactant side and product side. Here you can see there are two hydrogen atoms. For oxygen, two oxygen atoms, but on product side two hydrogen atoms and one oxygen atom. Okay, so this is not the balanced reaction because on reactant side total is 4 and on product side total is 3. This total should be same. So now step 3 is balancing. Now we will make one column table. R is for reactant and P is for product. In previous slide again, now here you can see two elements H and O. So we will write element H and O. On reactant side hydrogen 2, oxygen 2. So reactant side hydrogen 2, oxygen 2. On product side hydrogen 2, oxygen 1. Hydrogen 2 and oxygen 1. So this table can give you idea about unbalanced elements. So hydrogen is already balanced because on both the side we can see 2 and 2, but oxygen is not balanced because on product side it is 1. So what we have to do? We have to change something here. But while any change, we will not change the original formula of any compound. It means original formula of water is H2O. So we cannot write any number 2 or 3 whatever here. We cannot write number here. We have to write number here. Means in front of that compound. So just check here. So here we can see oxygen is 2 on reactant side and 1 on product side. So we have to add one more oxygen on product side. So this will become if we write 2 here, then now you can check 2 2s are 4. So here hydrogen become 4 and oxygen become 2. Again we will do same thing, 2 2 2 atoms, 2 atoms. Now hydrogen become 4 atoms because 2 2s are 4 and here 2 1s are, if there is no number then it is 1, so 2 1s are 1. Now again addition is 4 and here addition 6. So still reaction is imbalance. Why? Now oxygen is balanced but hydrogen is not balanced. So we have to add number at the reactant side. So this time we will write 2H2 plus O2 gives 2H2O. Now you can see hydrogen become 4, oxygen become 2, here again hydrogen become 4 and oxygen become 2, total 6 and total 6. So reaction is completely balanced. So from this we can say that two molecules of hydrogen react with one molecule of oxygen to form two molecules of water. So this was all about balancing of reaction. So how was it? Yes, this part was little bit difficult, not difficult but different than the previous video. So if you don't understand, then listen again, go through the lesson, read the lesson, you will get clear with all these new concepts. In next video we will discuss remaining part of this chapter. Till the time, stay home, stay safe. Bye.